So, what are we doing today? Well, I had some technical difficulties, to say the least, and I've lost the first video that was supposed to go as part of this, so I'll have to recap with the finished product at the start of the video. I'm sorry if that's disorienting. So, what's this thing with a button on it? Well, we ran into a problem. We've been using barbecue igniters, which you'll probably notice this black bit is from, to light our gas stovetop. And they keep running out of gas, and it seemed rather pointless to me to keep using a spark to light more gas, when I could just use a spark straight off the top. Let's see if we can see that here. It's rather interesting. Now, I used a little module that was donated to me, and the owner, or original owner rather, claimed that it was a taser module. I'm not entirely sure. In either case, it's a little black resin block with some wires sticking out of it. One of them had been busted off flush, so I managed to dig it out of the resin and make a new connection to it. And then the next project was to dismantle the original barbecue lighter and make it safe, so I don't actually injure my finger. And more importantly, my apprentice can't injure her finger. So the next video you're going to see here probably seems a little bit out of joint, and that's because of my difficulties. But we're basically going to jump to the disassembly point for the original barbecue igniter. And the rest of the things you'll see is the process of assembling and testing and sort of bumbling my way through it all. And I'm not real happy with the way this came out glue-wise, but it works, and I'll make a more refined version later. So let's jump through to the disassembly process. And I hope you're not too confused. Alright, let's find ourselves a reasonable view here. We'll pull that up. I really haven't got my setup back to normal status, so I might have to deal with some bodgy camera work, because, well, it's probably pretty normally bodgy camera work anyway. So I'm not sure how I'm going to get this open. These are notoriously difficult to get into. Thinking this might end up going out to the shed and get hit with a hammer. My supplies manager and financial advisor has just gone up the street to obtain another one, just in case I fail at this endeavour. Some people might argue that is planning for failure. Indeed it is, but I think it's sensible in this case. Let's go out to the shed and hit this with a hammer. Alright, we're out in the shed. Now my vise is handy enough to have a little anvil on the back, which is good for such destructive purposes. Now, before you get on me about the paint job here, this is a rental. I'm not responsible for the paint job. I'm just doing the best I can. Now, decisions. I think I really only want that end piece. I'm going to hit that right here. Can you see what we're doing? Yep. Wow, this is good ABS plastic. There's that shroud off there. This little spring section needs to come out. I think if I give this a gentle tap, I should be able to break the glue. I think that's the glue fracture. And that was nearly to my foot. Thank goodness for steel toes, which I'm not wearing. I'm just good at keeping my toes out of the way. Alright, we'll go back inside and finish the dismantling. Well, just like a Land Rover, there's a lot you can accomplish by hitting it with a hammer. Now that's the main piece I want right here. Oh, they're a bit stuck together. Here we go. Well, I shook things up. Now this is quite predictable. Here's a standard non-refillable Bic lighter at the heart of everything. There is a little hole in there. Makes me think I might be able to refill it. We'll try that. Oh, piece of cast aluminium in here for the safety mechanism. And some more glue. Some useful bits here. This actually might be good to repair some other lighters I've got. I'm pretty sure the local tobacconist thinks that I'm a massive weed smoker because I have all these different little gas torches and stuff like that. I use them for doing a heat shrink and hot glue and stuff. Now this guy has a problematic igniter, and that might be long enough to fit it. So I might end up repairing that with these excess bits. Never hurts to keep them tucked away. But the real part we want is this, and this is nicely insulated and grounded to do the job. Although I fear I've just pulled the lead out of here. No. So this lead here is free floating. We'll find out how that works in a minute. I'm going to stop the camera for a minute and do a little bit of investigating, and then I can be back and sounding like I knew what I was doing all along. So it turns out I knew what I was doing all along, and that's my story, and I'm sticking to it. This little insert is actually a little Teflon plastic insert, which makes me feel a little more comfortable about the way this works. But here's our little tube in here, and this all opens up as a little clamshell here. That opens up very nicely. It's a nifty little design, which means I can remove the plastic gas tube and the other wire that's in here. We can, hopefully you can see how this is arranged here. There's my apprentice yelling at the TV. I think that's a genetic thing. Her grandmother does it too. Don't tell her I said that though. In any case, that looks like our center conductor, so I don't think we need the gas nozzle here. I think we can just rip that whole thing all the way out. Sounds like my apprentice is having a chihuahua moment. I need to probably go and investigate that, and we'll be right back. Okay, we're back after some issues. We'll investigate this bit later, and we're going to put all that stuff aside. Don't need any of this wiring. We just need these two components, which is what I want to start with. This is a little misshapen from the hammer blows, but we'll fix that later. So I'm going to put a conductor up the middle here, and I'm going to use the outer shield of this as the other conductor. Feels like there's some other stuff floating around in here. I'll fish that out shortly. So what I'm going to make the conductor out of is some nice silicon cable. I got a little deal of this from AliExpress, I think, and I've got some of this nice stuff. It's really flexy stuff that's nice to work with, and it's high temperature, so I think I'll lay a little bit of that in there. I'm going to use that as our main conductor, and I'm going to have to use a couple of layers of heat shrink insulation for this, mostly because of the voltages that are involved. I think it's somewhere about 15,000 volts, but about 10 milliamps or even less, I think. I've got to go back over the spec sheet, which I think I lost some time ago. So I really do need to be careful to do this safely. So I'm going to do a little bit of finding of parts, and we'll be back and I'll show you the progress as we go. The next bit of progress, I'm going to tin the end of this silicon cabling here, and it's a little bit unusual to work with if you're used to working with normal wire. I think this is already tinned copper, but I need to just reinforce that tip. So for that we'll use some solder. It's 6040 tin lead. Lead-free solders for chumps, or at least I think so. My doctor probably doesn't. Last time he got a lead count in my blood, which, as it turns out, I'm on the low level of the spectrum for lead workers. So you'll probably notice that in the background here I have this tube which is evacuating fumes, which helps me breathe in a few less fumes and hopefully not get so struck by lead poisoning in the future. So here we go, we're going to lay this into the tubing here, and I'm going to just extend that. I think this diameter will fit just nicely. In fact, I think if I do this right, that should just protrude a little bit out. I'll trim a little bit more of this out, and we'll get this right. This is very much a creation as I go along. This is not something I've really planned out. With a middle ear infection, I've had to stay indoors and not move around too much. So this is pretty much a project to keep me from going insane. So I don't like stopping. Alright, let's fold this over, and we should be able to get that in. So there's our center conductor. Oh, and it fell out. Well, we might need a little bit of hot glue in there. Well, it is Teflon, so I don't know if hot glue's the job. Apologies for my apprentice in the background. She's apparently happy again. Don't really understand it myself, but you know. I see. There is a little clip in the middle here that holds the tube in, which should hold the wire in as well. And that should work perfectly. There we go. There's our center conductor. The next job, I think I'm going to have to grind some paint off this and solder it to it. So that will be a jump cut. I'll see you shortly. Alright, now I've managed to scrape some paint off the end here. I've inserted our Teflon liner with the silicon cable hanging out the back here. Push this in a bit. This is steel, so it's going to require a little bit of heat, but my iron is nice and hot. I've chosen the corner there simply because I can apply less heat to achieve the same result. Okay, we need a little bit more cable. I'm using the blue stuff here simply because I dropped the box, and as it was falling I used the blue cable to grab that. I've just realized I probably don't need to actually use that for the second cable. This was damaged when I got it, as we can probably see here, so I had to attach directly to that, which I'm thinking I might remove that and connect our silicon cable directly to that terminal, and then use this one here. That minimizes cable joins. So I think that's about the length of cable we want. So just to save you some boring soldering stuff, I'm going to jump to the next bit. Alright, so I have things all soldered together here, and I have my battery. This is time for smoke test, and this actually might make some smoke. So we're going to test and see if the arc gap is good. I think that's going to work just fine. Plenty of loud arc, it's got a lot of heat up. I think that should be good to ignite the stove. And before you ask about this whole project, no, my stove doesn't have built-in igniters. It does for the oven and the griller, but not the burners at the top. Seems a little silly to me. Okay, so I need to start thinking about a housing. Well, I hacked up a piece of aluminium tube in the workshop and put it on the rag wheel just for a little bit to shine it up. I think that'll make a suitable housing. And I should be able to house a battery in there, in this unit. And yes, it's metal, but so is the outside of this bit here. So hoping to keep it all commonly grounded to avoid sort of stray currents. I did find that there is a bit of residual current. There's obviously a capacitor in here. When I touched that exposed connection there, it gave me a good belt. So I'm glad I'm going to be housing this in something. I will be insulating that before I put it in there too. I also found a little project box surplus to another use, so I'm going to raid the switches out of that, and I'm going to do some pilot holes in a moment. So it's out to the workshop again we go. Okay, well, I had a few technical difficulties in the shed. Nonetheless, I got my hole drilled. Now I'm just using a standard push button here. I originally was going to add a safety switch, but I made a mock circuit and handed it to my apprentice, and she operated even two switches linked together and still achieved the end result. So I think we're going to have to look at administrative controls instead of mechanical ones. In any case, this switch mounts through nicely here, and I'll do it easier when it's off camera. In any case, all of this is going to mount in this tube very nicely. The switch will be on the front. My battery will hide in there. I'm going to do something not entirely recommended with the battery. I'm going to solder to it, only because this is for my use, and in future I'll probably end up putting a single battery holder in there. In the meantime, I'm going to use regrettably tape to fill this in until I can find the time and the balance to get out to my laser cutter and cut nice little concentric shims. But we'll start out with this, and we'll test and see if the principle works, and then we'll refine the design a little bit. We're up to the potentially dangerous part, although having had some experience with this, and before I get started here I should say, don't try this at home. It's a bad idea, for obvious reasons. If it's not obvious, you probably still shouldn't do it anyway. They do actually crimp caps on the end of these, which is what we're going to be soldering to. It helps a whole lot if you get some of the coating off them. and give it a little roughen up on the top and the bottom. You don't need much, especially considering the current we're dealing with here is not great. Alright, so what I'm doing is I've got my iron nice and hot. It's well up about 600 degrees. And we're going to tin it. This is flux core lead solder, and I'm going to lay on the top here and push firmly on until it starts to get in and immediately remove. You don't want to do any more than that. Having had practice with this and a little bit of experience, I find that the risk of blowing these batteries up is pretty low, but the risk is still there, and it's one you accept for yourself. I'm not responsible for that. Alright, so I've got some tin done on there. We'll let that cool off to the side for a bit. Now I need to sort out the battery wiring arrangement here. So I think we're going to keep our ground wire isolated, and we're going to switch our hot wire. I'm going to leave the original length of wire on here simply because it's not replaceable. So I really want to leave as much as we can. Owing to me, I'll probably repurpose this for something else later on in the future. We probably want some fume extraction over here. Okay, we'll want to tin the other cable here, making sure to keep away from that exposed high tension terminal that I got bitten by before. We'll twist all these in and give them a solder. Alright, now to prep the switch and some extra wire. Okay, we're up to doing some soldering here. I'm going to solder our negative wire directly on, making sure to keep the temperature low. I've actually just directly soldered into the little solder blob I have there rather than heating up the top of the battery too much. Now we have some of the original wire we extracted from the original igniter, or barbecue lighter, whatever you want to call it. Doing the same deal here. This is good solid core stuff. This will carry a little bit of current, but also it's easy to train. Now from here we're just going to hook up our switch. We can probably see from here if I touch these, oh, we don't actually have contact. Interesting. That warrants further investigation. Oh, here we go. I think we have some alignment issues. I need to check this out. I'll be back. Indeed, there were some alignment issues, so that should work. Time to add our switch after we thread it into the body. Okay, so I've got most of the components mounted and ready to go, and we can test. It's going to work rather reliably. My apprentice is still storming up and down the hallway. I should probably go investigate as to what that is, or what it's all about. But I think what we're going to do is loosely assemble this and go and see if it works. And if it does, then we'll manufacture some proper good looking end caps and try it from there. Alright, we're in my apprentice's territory, or adjacent to it. I have to ignore some of the production noises going on, and I've just realised one of the burners is messed up here. We'll move that later. In any case, we're going to use this guy and we're going to test our improvised igniter. There's a big blob of blue tack in here just to hold it together for testing. And I think it's time for a coffee. So let's see how this goes. Turn our burner on. I think it's going to work just fine. I think it's going to work very, very nicely. Let's try one over the back here. Yep, I think that's going to work perfectly. Alright, coffee time. There we go. Alright, time to manufacture some good end caps after the coffee. Alright, it's time to get stuck into some CAD. So I'm going to need to measure the internal diameter of this pipe with my digital vernier calipers. There's a bit of slag in here too, which might not help. So we're looking at about a 28.5mm tube. Seems strange, it should probably be a little bigger than that. And we'll check our diameter here, which is going to be 11.7, 11.6. So if I make it 11.5, there's about a 0.5mm tolerance in the cut, so that should be good. Alright, so we're looking at AutoCAD here, and possibly the simplest drawing I've done in a long time. So we have some 28.5mm circles, and the same thing with 11.5mm in the middle. And when my laser cutter cuts, there's about the width of the cut for the beam is around about 0.5 millimeter, so we'll add 1/4 mil, or probably 0.5 mil overall to the cut, which should just drop in very nicely. I won't really need to compensate for anything. So let's go stagger out to the laser cutter with some help and see what we can do. It's kind of noisy in here, and I'm sorry about that, but the microphones I've got are malfunctioning. What I need to do here is just set our cut depth at the moment. So this will come up to the autofocus pin here to indicate the depth and put it in focus. Rightio. Alright, now I'm going to go load the design up on my really messy desk. Alright, we're over at my super messy and super dirty workbench, but we're just about to queue up the design we did. That's, you'll probably recognize that. We're going to send that over to our laser, and we'll run along over to our laser, and we should see the files have come up. Alright, and it should be pretty standard. We shouldn't need to do much else. So I'm going to stick this in the bed, and we'll do the cut. I might even put some fancy music on there. Done. So this is just to test the fit, and looks like a beautiful snug fit. Will work just nicely, and this should slide right up to the end, and that should, if we duck under the switch, that'll fit in nicely. I'll have to maneuver the switch slightly, but that will be easy enough. This end went in so snugly it wouldn't come out again, and I'm going to use probably a little bit of this stuff after a little dob of hot glue to hold things in place. So I'll get all that done and I'll show you the end product. Okay, we have a finished product. Not quite as neat and as clean as I would have hoped, but it certainly looks better than Blu Tack. And again, this end went in a little bit cockeyed, and I realised I'd forgotten to clean up the inside edge, so that might happen later, but it's functional for now, and we can see in here it works quite well. So let's go and try another cup of coffee. I'm going to have the caffeine shakes by the time I'm done with this video. My apprentice is here to help. It's time for another coffee. Let's try this. There we go. Worked well. Have to fix the other burner up, but yeah. And we might even try the one over behind. I think it's going to work just fine. Alright, coffee time, and I'm going to calm down the apprentice. And that's the end of this video. Hope you've enjoyed it.